out in the back. Can you hear me? Yay! Okay, so first audience reaction. Awesome. So first of all, I'd like to thank you that you came here so early. God knows I have a problem with this too. I will do this from now on, by the way. My name is Zbyszko, and I'm here to talk to you about communication, like the soft skill communication, mostly at least. I'll try to compare it to some computer-based things, but make no mistake, communication is my main focus. But before we start, have you heard this one before? It's like sixth meeting on a subject. You have to do some feature, like something new on a UI or something else. The sixth meeting that goes without any actual decisions, but the need for, but you know that you need another meeting. PM is nowhere to be found. So when you actually want to start the project, some single guy who knows anything about the core of the system is actually on a sick leave, so you have to wait for him. And projects, and this takes about half a year before you even start working on anything else. I don't know how about you, but that happened to me at least once in my life, probably more often. So it's difficult for developers to work like this, right? But to be honest, that's not only from developers' perspective. I will tell you something from my life which I find very important. I wanted to be an architect. Like my dream when I started programming was to become an architect, would be this guy who's working with stuff like this, you know, the drawing diagrams, the risk management, the decision making, and so on. So this important stuff in computer development. At one point in my life, I actually became a developer, but my actual work was more like this. So basically, you had, well, actually that would be my best day. My most days would look like a conference schedule, you know, 3 tracks, select the meetings you want to go to, and say thank you to everybody else. So no real time to do any other work than just meet with people, and of course everybody were adamant about the fact they have to be on this meeting because it's a very important meeting. And mostly 3 of those meetings were at the same time, so prioritization was kind of difficult. Am I standing too far? They told me to keep this area. I'm quite restrained here. So I see both the problem that developers have with the project planning, the decision making, and this thing here. This is all the symptoms of the communication that hasn't been really designed. Like we tend to not think about communication as an important thing. We just like do it ad hoc, which is what happens in the most organizations. But the solution is of course simple, right? We have to communicate better. Like very simple solution to a very complex problem. Those are the best ones, right? But it's not true. Actually, communication itself is problematic, and both in terms of quality and quantity. There was this man, Jeff Bezos. He created a library or something. Bookstore. So when asked with a similar conundrum to how to make communication better, he said that communication is terrible. And I'm actually a firm believer of this, and I will provide you some examples why I think that's true. But before we start, I have a quiz for you. There will be a movie played right now, and I'd like you to count the white team passes. There will be a server after this. Please work. Yes. Okay, so let's go to the survey. Who counted the 16 passes? Oh, actually quite little people. Who saw a gorilla? Okay, that's awesome. That's actually the first time more people counted correctly and saw a gorilla. But have you noticed that the black teammate left? Nobody? That's also the first time, by the way. And did you notice the change of the color curtain? Single person. Okay, so this experiment is actually quite complicated because many people actually know this. There was the first version of this that showed the monkey going through a room, and that was it. And the experiment name is Monkey Business Illusion. So naturally people expect monkey somewhere there. But there are actually a few other layers of this, as you can see. And why I'm even mentioning this? Well, one of the fallacies of communication that we all have, it's like imprinted into our brains, is that we consider us as an objective observer. Maybe not we know that opinions are not objective by definition, but we consider some facts as objective matter. Like, you've been somewhere, you've been in some meeting, you saw something like this movie here, and you assume that you know what happened, which is not true, because the actual problem is that your focus defines your perception. So the way you think, the way you are, the things that are important to you actually define what you see, what you hear, and so on. That's one of the fallacies of communication, but that's not the only one. I told you that there will be some computer-based examples, so let's get right to it. Imagine there are two services. One is a PSA service, and the second one is a weather service. PSA service PSA stands for Public Service Announcement. This is an American service that provides some announcements to public, like some extreme weather cases and so on. Weather service, of course, is a service that provides weather information. So basically, PSA service is based in the US, and weather services was created by Europeans. So let's imagine a communication between those two services. How's the temperature? It's 30. Well, in the default, our default setting is degrees, right? Of Celsius. What's the wind speed? It's 30. Again, it's kilometers per hour, of course. And when should I ask for the next update? And here we have a standard Java timestamp, milliseconds from the epoch. I think you can imagine what happens next. The effect of this communication: first, wear more clothes. Of course, it's 30 degrees, right? It's quite hot, but wear more clothes. There is a hurricane, and the next update will be in the year 50,599. Of course, you probably guess what happened here. When PSA service asked about the temperature, it assumed those are Fahrenheit. It's about -1 degrees Celsius or something like this. As for the wind speed, of course, they assumed miles per hour, which is 2.5 faster, so yeah, quite fast. And of course, the issue that most of you probably had, those are not seconds, but we thought they are. So the next update will be quite far time in the future. Okay, that sounds like something that's easily fixable with well-defined APIs, right? So that's not something that computers have a lot of problem about. But actually, those things happened. If anybody asks you in your life to visualize what is a 16-bit integer unsigned, you can show him this picture. Basically, this is the place. This is an Ariane 5 rocket, although it's maybe not obvious. Or this was Ariane 5 rocket. And this place here is the moment when the 16-bit integer ran out of the overflow when it described the relative velocity from the ground. So there was some place in the code that translated float speed to the integer one, and at some point the speed became not what it's supposed to be, and everything blew up. It was launched by European Space Agency, and the cost was about $7 billion or something, and it just blew up. But not only Europeans do this. Meet the Mars Climate Orbiter, although orbiter part is not really true, because instead of orbiting, the probe actually crashed to the surface of Mars. Well, I think you know the story, that boy meets girl, girls design a piece of software that uses imperial units instead of metric ones, and boy launches the satellite in the air, and assuming it uses metric ones, and it crashes. Funny part about this is the thing that was sent by NASA, by the way. They actually provided a specification, which, being the specification, actually stated that the units should be metric ones. But Lockheed, for some reason, didn't design it this way, and sent out a component that used the imperial units. And of course, that caused a problem at some point, and this piece of engineering magnificence crashed to the planet instead of orbiting one. NASA decided not to pursue, by the way, didn't sue the Lockheed, even though they stated the correct specification, because they decided not to do it because they didn't actually test this. They didn't actually check the components before sending them out to space, to the other planet, which is interesting, by the way. So this happened because people who write software made some assumptions about the software they are working with. So this is not actually a computer problem. It's a problem that we all have, and it's based on us. I'll give you another example, more human-related. At some point in my life, I was attending a workshop that part of this workshop was to discuss some things and then describe what your partner told you about something. So at this point in his life, he wanted to build a house. So he was quite into it, and he decided to describe me how the house should look like, what is he interested in. I was, by the way, also interested in this, so I had my own point of view on the subject. So he told me that he wants to have a large house with green garden and in some pleasant neighborhood. So he actually meant something like this, some lawn, the house, quiet neighborhood. Well, actually, I understood something like this. In his mind, 300 meters was a large house, and my 3,000 was more like it. And it's green, right? It has plenty of green, only green. I think it's in jungle. So yeah, it all fits, right? It's a large house with a green garden and in a pleasant neighborhood. I don't think there's any neighbor around for 3,000 to 5,000 meters. So I would consider it a pleasant neighborhood. The less neighbors around, I consider the better. So in my case, it means that's the pleasant neighborhood. But he meant something else entirely. Why does this happen? Well, basically, we all define our stuff, the things we say, based on our own experiences, and we assume those experiences later on. So it looks, for me, the large house is 3,000 meters, for him is 300. And other things that doesn't really match. We use the same words, but you can compare this to building some structure, the same structure, but using different blocks. To get back to the IT world, we auto-wire some meanings to the words, right? So, but those meaning is not always the same meaning that the people we speak with do. So it's quite often that even the simple message is not understood the way we wanted it to be understood. Those are the two things I consider most important about fallacies of communication. But communication itself can be a problem. Quick show of hands, who knows the Universal Law of Scalability? Oh, that's very nice. Oh, yeah, okay. So at some point, at some presentations, everybody in the room will raise their hands and I will not know what to do. Okay, so Universal Law of Scalability, in very broad terms, tells you what kind of gains you can expect from scaling the system, providing new threads to some calculation, expanding the load, and so on. And it says that in basic situation, when you only have to contend for some resources, some database and so on, it looks like this. So you get some nice returns here, like in the beginning. Then you go, it's called diminishing returns. So with each of the new instance, with the expanded load and so on, you're getting only this much of actual performance gain. So you will never get unless you have a calculation that it's called embarrassing parallelizable or something like this. You won't get the perfect linear performance gain here. But that's actually not really problematic. This here is the screen is too big. This is the thing that actually causes the performance loss here. But the problem is when you have to actually communicate between your threads, your processes, and so on, it becomes more complicated. Since actual impact on the performance is quadratic, you have some point in time that expanding the load or adding new threads and so on will actually cause you to lose performance, not gain it. So there will be a point in time that will be an optimal space if it comes to performance, and then each next will actually make you lose performance. Why is that? Well, basically, it's because of this. So when you add something, you're adding communication lanes to your algorithm or your computer and so on. And each of those, in the worst case, can give you and n-1 additional roots, which translates to the mentioned quadratic loss. And this not only happens to the computers, it's the same thing with humans. Who of you knows this book? I highly recommend this. This is a book from '75. I will make this point again, but most of the fun things in IT were invented 40 to 50 years ago. Nothing new since then. So basically, Frederick Brooks was hired by IBM at some point. IBM wanted to create their own operating system. They had those big mainframes, you probably know, the hardware that most people used back in the day. But IBM wanted to also handle the software side of things, so they invented OS/2 system. Problem was that by the time Frederick joined IBM, the product was already very late. And at this point, they actually thought it would be best to hire more engineers. So they hired like it's like 2 times the number of people that were right there. That's probably not a real number. And basically, what this caused is that project was actually even more late than it was before. There was two things that were the reason for this. First one was that, of course, each of the new people have to be trained in the new project, have to understand the source code and so on. But the second one was based on this thing I just said. So basically, adding so much engineers expanded the communication routes, which meant that communication had a huge impact on the project itself. Up to the point that it actually caused more project to be more late than it was before. So when it's called Universal Law of Scalability, it's really actually universal. It also handles people. So that's the problem I have, and many people have with communication itself. It can be quite a difficult process to handle. But there are some things we can do about this, and there are some things that are related to programming that also relate to communication. First thing I want to talk about is Conway's law. Who of you knows Conway law? Oh, that's quite nice. So basically, Melvin Conway stated in his white paper about designing by committee. Actually, it was not about this. It was like a single paragraph in the whole paper. Organization with the design systems are constrained to produce designs which are copies of the communication structure of these organizations. Basically, it states that when you have some structure, some teams and so on, the structure of the teams, which is basically structure of communication, is mirrored in your designs, whether you want it or not. Actually, the funniest way of describing is if you have 3 teams that are tasked to produce a compiler, you will get it to 3-phase compiler. So, by the way, it was made in '68, so another fact, more than 50 years ago. Like I said, everything fun was created like 50 to 60 years ago, nothing new since then. But this thing was actually, the law, we now call Conway's law, wasn't actually a main thing about the document, and it was largely unnoticed for many years, until 2007, when some people actually decided to see if that's true, and they did a survey on a number of organizations to see if this law holds, and it does. Okay, so I said we can do something about this. So basically, like I said, it's true whether you want it or not, so you can either try to fight this, and by fighting it, I mean you have many teams that work on the single project, try to commit in the single modules and so on, and fight each other. Or you can divide your architecture and actually create and make teams work on the contexts, which will make them probably more productive. Thing I find most similar about this, but I don't know, this book was also already presented in this conference, and I think it will be presented again by this guy there. So basically, you probably all know the tactical part, since it's quite popular, but not many people actually are interested in this, what I call strategical part of domain-driven design, which is actually more or less about how to well, at least for me, how to manage your team's communication and services they produce. For example, you can see here, it's very simplified, by the way. The pictures are there. So basically, if you have some teams, I will try to use it again. Oh, here it is. Some teams that have some parts of a project that can have a similar business goal. For example, accounting and pricing here. That's probably not true. They should have like a very close relation to each other, like maybe the same room, maybe the same product owner, and so on. So basically, you have to make communication between them easier. But it's extremely hard for larger organizations to have a perfect communication between all of the teams. It's just too straining. It's just the universal law of scalability, basically. So you don't have to have such a strong relations between pricing and delivery. In this example, product discovery and inventory, and so on. So I won't speak about it much because I will probably have to have 2 or 3 additional hours to do this. But I highly recommend the book. I don't think I've met the person who read it, read every page of it. It's quite large. And Evans, who created it, actually has this very useful graph in the beginning that shows the pages with some terms you can just skip to and read what you're interested in. But it's still a fun read, at least if you do it responsibly. Okay, so I already talked about the problems with communication, both in quality and quantity, and how it maps to the structure of your organization. So let's take a break from this and go back to more personal subjects. So let's start with how the context switching in the processor works. I know. Okay, so basically you have some process. You want to switch to a different process, so you suspend the state of a process. Then you store the state of the CPU from this process. Then you restore the process and restore CPU state and unsuspend the new process, B in this case. Well, we humans also tend to context switch, which looks quite similar. We suspend working on some task. We save the work state of this task. Then we restore the work state of the second task and suspend working on the second task. Almost the same, right? There are 2 problems with this. First of all, we don't really have a good way of storing our brain state. If you work on something, especially if it's code, and you see all the variables, APIs, and so on and so forth, it's difficult actually to drop it, place it on some piece of paper, the computer, or so on. It's almost impossible. And the worst thing is that this barrier, the restoration of the work, is actually much, much more difficult. Once you start working on something that requires you to understand the code, sometimes it takes half a day to understand what you're actually reading, right? It takes an additional time to actually start working on this and understand what are the dependencies, what do you actually have to do with this. This is the issue that processors also have, but it's much easier for them since they can actually store state. But even in the case of our computers, they are doing things that can optimize the process. For example, the simplest thing you can do is not to context switch. Easy, right? So just don't do it. There are no real gains unless it's something of an emergency to constantly switching between tasks, unless you really have to because you cannot work on a single task. But if somebody asks you to do this, like your project manager or somebody, you can show them this picture. Let's imagine you have 2 tasks, task A and task B. Each of those takes 5 hours, and those the small blocks are here. Let's assume, and it's a very, very optimistic assumption, that your context switch within the task takes about 30 minutes. It's not true for me, for example. So imagine that you do tasks 1 by 1, so you finish one, you start another. The mean time to end the task is actually 5 hours and 15 minutes, so quite nice. Even if you count, no matter how you count it, this looks very good. If you do a context, then the worst case scenario, like this one, it actually takes 13.5 hours to do this, so more than 2 times more. So this can be actually quite, I think you could convince many people with this. If most of the things you get are not really that important that you have to drop everything you're doing now and start doing something else. And I know that many of us has this thing that if somebody asks you to do something and it sounds simple, think, okay, I can do this right now, right? So not a problem. But the problem is that you're actually dropping what you're doing now, and you have to restart. Well, you have to refill those caches. Your CPU has to be working on this task again, so you have to fetch something from files in your brain and have your brain state restored. So the best thing here to do is just ask not to do. Other people not to do this. But that's not the only thing you can do. Well, actually, the issue here is that if you want or not, you will have to context switch. So basically, there are these two kinds of jobs: deep work and shallow work. Deep work is despite a part of your work where you actually, for example, coding, right? So you have to go deep inside. You have to have like I said, those caches filled, and it's very difficult to get back to it once you stop doing something. And you have shallow work, which requires you to have like a broader perspective. So, for example, any form of communication, the design process, and so on. In most cases, most of us have to do both. Well, we are, I assume, mostly here programmers, so we do a lot of deep work, and many of us have this tendency to like enclose yourself in it, right? That's the thing I like to do about this job. I like to code, so I will do it as much as I can. But doing shallow work, the communication part, is almost inescapable, so you will have to do it anyways. So what can you do about this? Well, idea is simple, and it was actually mentioned a few times. Have some boundaries. Like in my case, it's like a 5-hour block in my calendar with no meetings inside. Mostly I just disappear from the Slack or at least turn off the notifications. At some point I actually disappeared completely, like went somewhere else where nobody can find me. But of course I always had this like discuss with my friends where I am if I was to be needed. That's one additional important thing. You have to, that's smoke signals. I hope it looks like smoke signals. You have to talk with your team and decide how you want to communicate. So tell everybody you have those silent hours or work hours. And by the way, the name work hours is strange. What you do after this, not working. But have this communication like laid out. Know how you communicate with each subject and how do you communicate when you are doing those work hours. Basically, there's nothing worse when you are working on something and somebody comes to you and, hey, did you see my email? I sent it to you like 5 minutes ago. Did you have the chance to read it? No, I didn't. Okay, so basically have this communicated throughout your team. Okay, that's context switching. Actually, my favorite topic about how communication of the computer is compared to the hours we do every day is our meetings. I'm not really a fan. Let's start with synchronize. So, actually, it's some locking mechanism in, let's say, Java. What you see here, there are some operations before the lock. Once the lock is established, there are two things that happen. You have to actually update on the operations before. It's actually done by flashing the read-write caches in the CPU. There are different names for this, but that's basically their function, because once you enter here, you have to know the current state. Same as with threads and context switching, our CPU can reorganize our code so it's more performant. You know, there are those caches in CPU that can hold a limited amount of memory, and Java does this too, but CPU does this also. They reorganize our code so that the access to memory is more optimal. But once you synchronize something, it all goes down the drain, simply because we need to have those information right here, right now. So basically, that's why when you synchronize, everything goes slower. Even if you have a single thread application, it doesn't change a thing. Actually, it does, because if you have more threads and you actually have a contention on the lock, there's also a context switch in the meantime. And then you unlock and do something else. In human terms, it looks quite similar. You work on something. It's an extreme case probably, but you work on something. Sorry, I'm not without a head for something. Never mind. So you work on something. For some reason, you have to stop working on something because I don't know, you have to have some decision on this maybe, and you start working on something else. So once you start working on something else, there should be a meeting about the thing you were working before. So what you do, you have to like drop everything you're doing now. You have to update yourself, so synchronize yourself on all the data available on A to be prepared for the meeting. That's the optimistic part, when I assume that people actually prepare for the meetings. Of course, you have to do a context switch. Then you are working on the meeting on something related to A, meeting ends, and you do have to do context switch again. Or if you're lucky, you can probably continue on A. It's still very complicated. Like I said, humans have a problem with context switching at least. And the second thing is that you actually have to get all the people in the room, which is quite complicated most of the times. Well, again, software does provide us with some solution to this, at least in most cases, and it's called asynchronous. So I wanted to place Eric's Java here, but basically what this means is that most of the decisions you make in your work are probably not that important. You have to gather everybody for an hour and make decision right here, right now. Most of those decisions can probably wait like for like a day or two or maybe more. So instead of gathering everybody and forcing them to apply to your schedule, not to theirs, do something like this. Create a Daisy. Daisy is one of the plays from the Atlassian playbook. This is like a thing that Atlassian describes their own practices online. It's quite fun, and Daisy is my important thing. Daisy stands for driver, approver, contributors, and informed. I will describe them soon. So how does it look like? First of all, you create a tracking page. Basically, the thing you have to do here is to make some kind of a decision, mostly a technical one. For example, which way to implement something, what's the better approach of doing something, and so on. So tracking page explains the context of the decision. For example, why are you doing this, why are you thinking about this, and what are the constraints you have in your system. And also should provide you with some alternatives, like at least few ways of solving the issue. And by the way, I highly recommend that you place the empty option, do nothing option. Well, sometimes it's actually a valid option, like you don't have to change anything, and probably consequence will not be that severe as you think. In other cases, it may be just fun to analyze what would happen. So once you have this context, those potential alternatives and so on, assign the roles. And roles are the things that create this acronym. Driver is a person that is responsible for handling the decision process itself, like the administrator of it. It's mostly you, basically, if you create the page. Approver is the single person that can actually make the decision to go ahead with something. Contributors are the people who are affected by the decision. In this case, I mean, for example, your team. If some decision is made, they have to implement this. And informed are the people who are impacted by the decision but have no real say in the matter, right? People who will be using your API or some other stakeholders. Once you have those roles, define a plan. By plan, I mean when the decision should be made, what happens after the decision is made, and so on. And once you do, involve the team. So send out your page. In my case, it's mostly like a wiki page created on Confluence, which I send out to the team. Well, Confluence actually does that for me. And I give mostly like 3 days to decide something. And after some time, either the decision is made, we can close the deal and go home. But more often than not, unfortunately, there are always some people that are not convinced like entirely that this is the right approach, and we'll discuss this on comments like forever. So unfortunately, sometimes it is just the time to meet. Yeah, I don't like meetings, to be honest. I consider most of the meetings I was attending as a complete waste of time. But there are sometimes necessary. For example, if you see as a driver that the decision is like taking forever, you should meet with people that are responsible for this. So basically, what you have to do to this meeting to be successful, first of all, be prepared. Like, there's nothing worse than the single person that comes in and knows nothing, and for the first 15 minutes you have to update him about the status of things. So be prepared. And in the other case, if you're creating the meeting, please give people time to be prepared. So not maybe 15 minutes time of preparation, but maybe a day, for example. And other thing, after the days, you probably know what is the group of people you need to meet with. So do not invite the whole team, the whole department, and so on. Find those people who have actually problem with the decision and gather them around and make them discuss the subject. Another important thing is, and I'm a huge hypocrite about this, do not use any kind of distractions. So laptop is only allowed for somebody who writes things down, the one who presents something on the screen. You should definitely not use cell phones and so on. I know it's difficult, but because people tend to think they have like this split attention thing, which is, by the way, debunked. There is no such thing as split the attention, so nobody of you actually has this. And when you're using some devices during some meeting or talk, you will not get the full information that is there. And it's important since you don't want to waste anybody's time, right? And for that matter, it's also important to have a focus. Like, have an agenda. Always have an agenda. The best agenda you can have contains single point, of course, like, single responsibility rule for the meetings. But in this case, if you have this agenda, you have the lower number of people than all of the team. If you are prepared, it's quite possible to create a meeting that is short, like 15 minutes short. It's actually possible to have 15 minutes meeting that actually produce some results. As for the results itself, first thing you always have to have is an action plan, action points, something that you have to do after the meeting. Even if the action plan is to have another meeting, that's also valid. But never leave the room without having an actual one. And it should be written down. Not only the action plan itself, but also the things that happen in actual meeting. Have a scribe, for example, some single person who will write down the minutes of the meeting or so on, and then read them out loud, so you know that everybody understood the same thing. Remember the first points I mentioned about the communication fallacies. They are still there. So reading out loud, saying what you understood from the meeting is a great way of checking if the assumptions are the same. Okay, so that's one of the things that computers have in common. But another one is scaling. Of course, we have microservices right now. I promised microservices. So yeah, microservices. So microservices are fun in this way that if something breaks, if you need more performance, you can always spawn another one, create another instance. If something breaks, you can replace it with some instance. Of course, you still have to remember law of scalability and so on. So it probably won't work that good as you expect, but it works nonetheless. I cannot say the same about people. Like the most of us have some expertise, so they are not easily replaceable with another, fortunately. And in many cases, there is this single person who knows everything about the core of the system. You don't know this person, right? So the single guy who everybody goes to when they have to ask something. So basically, here's a silo. There was a presentation about silos yesterday by Famigo, which I recommend. So, of course, I think silos are bad. Right? It's nice to have a specialized knowledge, but if your knowledge is about the project itself, it's very hard to do anything if you're not around. If you're sick, if you've been hit by a proverbial bus, it's quite difficult to continue. And I met the situation more than once. There are a few ways of doing this, and one of the more interesting one, I think, is pair programming. I know that this article that says it's harmful. We did this, and it's a great way of actually passing around knowledge, although it can be difficult to work with. So I highly recommend doing pair programming when you start something, when you have some decisions, or when you end some implementation. Of course, pull requests, code reviews are also a very nice way of doing this. But most importantly, write down things, like have an actual technical documentation. It sounds quite obvious, but you would be surprised how many people think that's not important. It's Agile, right? Who needs documentation when we're doing Agile? But that's not true. So all of this may sound like I hate communicating with people, which somebody pointed out to me yesterday that may be true because I like Uber because I don't have to talk to the driver. That's partially true, but I like talking to people. The reason I probably like talking to people is because I actually need it. Like each one of you needs the human interaction. We are not robots. Basically, I like this quote, but I seriously don't know who wrote it. I don't know this person, but it describes what I feel. We actually, many of the things we do are started and finished because of a social environment around us. And the fun thing is that we actually need this, like physically need this. If we isolate ourselves from other people, we get real life brain injuries. We develop some suicidal thoughts. We develop depression, and this was actually proven by science. Of course, that's not all bad. The thing I find most interesting is that talking to other people allows you to find a different perspective on things. So I know if you've been to the situation, I've been there many times, that you're doing something and was like stuck for like half a day or something, and this other person came in and just like after 50 minutes you had a solution which we were working for like less 2 days. That's because we tend to when you go deep, we really go deep, and we tend to focus on a single path, and another person won't have the same problem because he or she wasn't working on this. So talking to people is nice and quite important, but I rather prefer to do it because I want to, and not because the structure of our organization, of our communication, forced me to do this inefficiently. So I would focus on the social part of things and the perspective side of things, rather than long hours of meetings I have to attend to. Well, we discussed a few things that not only like compare communication to computer programs and so on, but actually connections between computer world architecture and so on, and communication itself. Basically, my thought about this is the communication is part of an actual architecture as much as your code is, or your diagrams are, and so on. It's an important part. Like Conway's law states, there is a direct correlation between organization and architecture, so it is important the same way. But another thing you can get from this is that you can actually influence architecture differently than only working on the architecture itself. So basically, it's called inverse Conway's maneuver. It means that you can organize, if you want some kind of architecture, for example, you want to have some boundaries here, you want to have more some less coupled environment. You can organize your structure, your teams around this concept. You can organize your work with your colleagues, your communication patterns this way that they actually influence your architecture. Basically, this all comes down to a single thing. It doesn't matter if you're a developer, architect, product manager, or somebody else that is a part of the process. You all are influencing the way the communication works in your company, and it's not a domain of those people that create those meetings. You always have a say how this should work because they are actually paying for your job. So with this, I'm going to leave you today, and thank you for your attention. We actually have a few minutes if you have any questions. There's a question. Love those.
The calculation of context switch time was very, very bad.
Oh, seriously?
Yeah, but because you said 5 hours and 15 minutes. But that was an average between the two tasks. And in the second example, you used the full time.
All right.
So actually, the difference is not nearly as big.
Both were full time.
What?
Both were full time. It's like
no.
Okay, it's possible. I actually made the changes.
The first one you said took 5 hours and 15 minutes.
Oh, you're right. It should be more like 7 or 8 hours.
It should be like 10 hours and 30 minutes because it was true. 5 hours.
Still too much. I remember the name too. I did the change like before this and probably did something bad here. But it's still like 2 times more, right? So
no, it's 30% more, but it's still bad.
Yeah,
I'm
it's
not
still
saying
yeah.
The conclusion is right, but it's just very bad.
Yeah, sorry for this. There will always be some mistake in the slide. I'm doing this for 4th time, by the way. So you're the first person who actually brought this up and actually did the calculation. So thank you, sir. But yeah, the conclusion stays the same. The context switching is difficult, especially for us developers, because it tends to take a long time. However you calculate this, and is it something that people that actually make you context switch think about, because most of their work is like this shallow work. They actually do a lot of communication, they do a lot of designing things and so on. So for them, this is actually quite natural to switch context quite often because it doesn't take that long of a time. So when somebody asks you to do this, please remember they can have a different perspective on things. So like the examples I told you about the different blocks that we use to describe our reality, that's the same for other people like managers and so on. Yes, they are people, actually. So they also think about context switching, but it's something completely different for them than it is for you. So tell them how long it takes for you to change, to switch from one job to another. Any other questions? Any actual questions? Yes? I hope no more bad calculations. Well, actually, I had a single slide that says something and it was wrong. That's awesome.
No, it's not about the calculation, but I want to know your opinion about because in my opinion, the two things here we need to implement together in the project. If we have a big project, we either need to invest much time into communication, or either we need to invest much more time into duplication of some functionalities. So which
could you repeat the last part? Or
we need to invest more time into duplication of some functionalities, because if we do not have enough communication, then usually that's what you said when talking about 3 teams doing similar things and doing them equally. So which kind of investment you would prefer?
Well, to be honest, the example about 3-pass compiler was actually you would actually have different parts of compilation. Like you actually would divide the functionality, but what would you get? You would get 3 compilers basically that maybe not do the same thing, but they are still not the single compiler. That's actually what happened. I think what happened in Oracle when they created the C1 and C2 compilers. There are 2 different teams that do this, but I didn't actually suggest we have communication that is lacking in this case. We don't have a full information. That's not really what I think. What I think is we have to have a communication that is relevant to the thing we're doing. So I propose one single exercise before you start. It's called communication points. It's a way of aligning the ways of communication, like, I know, instant messaging, the mail, and so on, to the problems you are facing in the team, in the project, and so on. For example, if I have something important, I will actually call you on your cell phone. But if I have something that can wait like for 1 or 2 days, I will create a wiki page and send it out to you. So basically, you have to have a full information. I am actually suggesting that you write down everything, to have a complete picture of things, to avoid as many fallacies of communication you can have. Write down things you are applying. If you think that the information is not complete, you should always ask for more. The only thing I'm suggesting is to actually think, how are you asking for those things?
Yeah, but the problem is you usually do not have. If you are not having some alignment meeting or some discussions by default, you do not even know that you are duplicating of work of another team or something like that.
Yeah, that's true. I would meet them. Like the kickoff meeting are fine for me, at least. I even do some form of workshops for this. Like I know that if I get people on the same page from the start, I will get less problems in the future, less need for the communication. So I would prefer to even have a full day for this, although I do not do those full day things, rather than having some things unsaid. So yeah, I would. That's probably a good suggestion. Just to start with some form of kickoff, maybe some fun one with pizza, beer, maybe. Well, not too much beer, although, but yeah, something fun, something that will get people to know each other, something that will make everybody understand why we are doing this thing. But it's all because we don't want to have those kinds of meetings later on, like full day things. You know what happens then? Like when people meet, there are like at least few people who won't listen to the meeting and so on. So it's better to start with something big and then have these communication points decided. How do you communicate things, and then you can start with your work. At least that's what I would do, and I actually did. Any questions? I have 1.5 minutes more. No, I think that's it. Thank you very much again.